Hi everyone, this is Siram Kanse from Balkrishna classes Sawantwadi. Today we will discuss few new points related to chapter Kinetic theory of gases and radiation. It is chapter in physics, 12th science physics. So first we will discuss about introduction of kinetic theory of gases. So matter having three common states, we know that solid, liquid and gases. So today we will discuss about gases. Okay, so first point is concept of an ideal gas. Ideal gas is depend on three different laws. First is Boyle's law, second is Charles law, and third one is Gay-Lussac law. Okay, so Boyle's law is depend on the volume is inversely proportional to pressure at a constant temperature. When your temperature is constant, then volume is inversely proportional to pressure. Is first law is called as Boyle's law. Second law is called Charles law. Charles law define volume is directly proportional to temperature at constant pressure. When your pressure is constant, then volume is directly proportional to temperature. And the third one is Gay-Lussac law is defined pressure is directly proportional to temperature when the volume is constant. Okay, these are the three laws. So according to these three laws, you got PV is directly proportional to T, or P1 V1 upon T1 is equal to P2 V2 upon T2. You got this expression this way. For n number of moles, we have discussed about this relation. What is the relation? PV is directly proportional to NT. N is defined number of moles. So and PV is equal to nRT. R is defined universal gas constant. R is defined, capital R is defined universal gas constant. So you got expression PV is equal to nRT. This is your perfect ideal gas equation. This is your perfect ideal gas equation. So what is the mole? What is the number of moles? Number of moles is equal to mass upon m. M upon m0 is equal to n upon na. M upon m0 is equal to n upon na. So alternatively we are discussed about, just I put the value of R, capital R, then I got PV is equal to n kBT. PV is equal to n kBT. So R is called n kB. So value of kB is equal to 1.38 into 10 raised to minus 23 Newton per Kelvin. This is the value. Second point is behavior of a gas. When your gas is enclosed in container, the gas having characteristics pressure, volume and temperature. When gas is enclosed in container, so gas molecules are present in the gas. So molecules having is nearly equal to 10 raised to 23 molecules per meter cube. The molecules are present in a gas is nearly equal to 10 raised to 23 is a large molecules present in a gas. How much? 10 raised to 23 molecules per meter cube. Okay, and this characteristics is called microscopic parameter are present. Which one? Pressure, volume and temperature. This is called behavior of a gas. So third one point is ideal gas and real gas. So in exam the question is distinguish between ideal gas and real gas. So today we will discuss first point. Ideal gas is not indefinite. Is not definite volume. Real gas is definite volume. Means what? Real gas having velocity, volume and mass, but ideal gas is having velocity and mass only. Okay. Second point, ideal gas is elastic collision. Real gas is non-elastic collision. Ideal gas is high pressure as compared to real gas, and real gas having low pressure as compared to ideal gas. Okay, and the last one is it is does not exist Ideal gas does not exist in environment. Real gas is exist in environment. Okay, this is distinguished between ideal gas and real gas. So next point, fourth point, mean free path. What is free path? Distance travel molecules between two successive collision. What I am saying? Distance travel by molecules between two successive collision. For example, this A to B. The molecules travel A to B between two collision is called as free path. So mean free path is depend on lambda 1 plus lambda 2 plus lambda n up to lambda n divided by n. N is defined number of molecules, capital N. And the second equation is lambda is equal to 1 upon under root 2 pi d square into n upon v. N upon v is called as density. Density is equal to number of molecules upon volume. So it's called density. So you got this expression. Which one? This formula is very important to solving a problem. Which one? Lambda is equal to 1 upon root 2 pi d square into n upon v. Okay. So last point is pressure of ideal gas. It's a very important. Pressure of ideal gas. So this is your cube, vessel cube. Consider gas, perfect gas is present in this cube. So obviously molecules are present. When molecules having motion, in that time it's having momentum. And the momentum is a three-dimensional. Molecules are moving in a three-dimensional XYZ plane. So now we have find out the momentum, change in momentum. So A is defined here, area of this cube, L square. V, capital V is defined volume, is depend on L cube. Small m is defined mass of molecules, and L is defined length of each side. Okay. So now we have find out the change in momentum. Okay. When your molecules present in a gas and is at rest, then is called as initial momentum, before collision momentum before collision. And when your molecule is moving, in that time is called as during collision, and when it stop is called after collision. So now we have discussed about the initial momentum and final momentum. When I subtract final momentum to initial momentum, then I got change in momentum. So I written here delta px. When suppose your molecules travel along x-axis. Suppose your molecules travel along x-axis, then what is change in momentum? So change in momentum is depend on final momentum minus initial momentum. So del px is equal to final momentum is minus mvx and initial momentum is your vx. So minus mvx minus mvx, you got minus 2 mvx. So now we have find out the momentum during collision is positive. During collision delta px is equal to plus 2 mvx. So now we have find out the time. During collision, molecules having a time delta t. Delta t is equal to 2L upon Vx. You got this one expression and this one. Which one? This one. Delta Px is equal to plus 2M Vx. Now we are find out the average force. So average force is equal to change in momentum upon time. You know, force is equal to momentum upon time. So average force is equal to change in momentum upon time. Just I put the values. Which one? This one and this one in this equation. So I got 2m Vx upon 2L divided by Vx is equal to mvx square upon L. 2 will be cancelled. Vx is comes to the numerator. Then you got m Vx into Vx is called Vx square upon M. So now we have find out average pressure. Average pressure is equal to along x-axis. We have discussed average pressure along x-axis is defined Px. is defined Px is equal to average force upon area. So now I put the value of this one and this one. Area is called L square. So I put here L square and this M, you got L cube, and numerator as it is which one, M Vx square. So you got average pressure is equal to M Vx square upon M. Now we have find out average pressure for single molecules. When molecule having momentum along x-axis, the equation is Px is equal to M Vx1 square upon L. What? Px is equal to M Vx1 square. 1 is defined for single molecules upon L. So for second, third, fourth up to n number of molecules, the equation is Px is equal to M upon L cube in square bracket Vx1 square plus Vx2 square plus Vx3 square up to dot up to n. So next, Px is equal to n into m Vx bar square upon n. These are the summation. So we taken a mean of Vx square. We have taken a mean. In that time it will be bar and n number of moles is present. So we got equation is Px is equal to nm upon L cube Px bar square. Okay. Similarly for y-axis and z-axis, the pressure is Py is equal to nm upon L cube Vy square Vy bar square. Pz is equal to nm upon L cube Vz bar square. We got the pressure along x-axis, y-axis and z-axis. So now we have find out the total pressure. Total pressure is defined capital P. P is equal to Px plus Py plus Pz. There are three pressures, so divide by 3. Okay. So now put the value of Px, Py, Pz. This one Px, Py, Pz. When I put this value, then I got 1 upon 3. Nm upon L cube is common, so take outside. What is remaining? Vx bar square plus Vy bar square plus Vz bar square. And this is called V bar square. This is called V bar square. This is the total velocity. Small v is defined velocity and capital V is defined volume. This is called volume. Which one? L cube is converted in V. So you got P is equal to 1 by 3 n upon V, not a cube, n upon V into m V bar square. So this expression is defined pressure of ideal gas. This equation is defined pressure of ideal gas. Which one? P is equal to 1 upon 3 n upon V. N is called number of moles, V is called volume, m is called mass of molecules, and V bar square is defined velocity of molecules. Okay. So today we are stopped here. If you understood this all point, then like me and subscribe.